And our last topic in kinetics is catalysts, or catalysts. All right, so let's make an energy profile. Okay, so this is the reaction progression, and this is the energy. And we have some reaction, and there's its activation energy. This one's also going to be slightly exothermic. This is the uncatalyzed pathway. A catalyst does this. That is the catalyzed pathway. Ooh. What does a catalyst do to the activation energy? A catalyst lowers the activation energy. So that means that a catalyst will do what to the rate of a reaction? If we have a lower activation energy, what is it going to do to the rate? It's going to increase the rate. So how do they do this? Let's write this down. Okay, a catalyst increases the rate of a reaction without being consumed in the process. Now sometimes catalysts get altered through the reaction mechanism, but they always go in and come out of a reaction exactly the same. So they are not consumed in the process. Okay, so a catalyst lowers the activation energy E sub A for reaction. Okay, and a catalyst can do this in one of two ways. The first way that a catalyst can do it is that it actually can bring the two reactants together in the correct orientation. So it can stabilize the activated complex. So instead of having to collide, and oh, finally we've collided in the right orientation. Sometimes a particular kind of catalyst will actually bring the two reactants, hold them together in just the right way so that they form an activated complex. And so it only takes one collision and the reaction will go. Biological catalysts, enzymes in living things do this. They have two receptor spots, they're proteins, they have two receptor spots, two reactants, and they hold those reactants in just the right way so that they can form their activated complex and react. So, a catalyst can bring reactants together in the correct orientation which stabilizes the transition state. Okay, so biological enzymes are an example of this. Surfaces can do that too, where the reactants can bind to the surface right next to one another, and then the way that they're bound will allow them to react, will stabilize their transition state. Okay, I think I read an example of this as in a catalytic converter in a car, and in the exhaust pipe of a car. It's got a catalyst surface that brings, and it must be nitrogen compounds. I'm not sure what it is. One of you can look it up though. Okay, now the other way a catalyst can lower the activation energy is that a catalyst can participate in the formation of a different intermediate. Okay, so they actually alter the reaction mechanism. So it's an alternate intermediate than what would normally occur in the reaction mechanism, and so in helping to form another intermediate, it actually alters the pathway. It alters the mechanism to increase threshold emission. So, a catalyst, I hope you can read this, a catalyst can participate in the formation of a different intermediate which provides an alternate pathway. That's how you'll always hear it in bio. You'll always say, oh, it provides an alternate pathway. Well, what does that mean, an alternate pathway? Which provides an alternate pathway or mechanism, right? It changes the mechanism. It changes the reaction mechanism. And with that change in the elementary steps of the mechanism, right, if we change it in a way that increases rate, that's what it's going to do. Okay, so they can work in one of two ways. All right, now, one very important thing about forget the color code right now, okay? A catalyst does nothing to the beginning potential energy of the reactants. It does nothing to the energy of products. So it does nothing to change the delta E, or as we like to say, the delta H of the reaction, the enthalpy of reaction. Enthalpy of reaction stays the same. Catalysts don't change whether something is endothermic or exothermic. That difference, okay, whether it be down here as for exo or above as endo, that difference always stays the same. Okay, it's not altering the overall enthalpy of reaction. All a catalyst is doing is lowering the activation energy so that the thing happens faster. So that's what catalysts do. They do not change the delta H of the reaction whatsoever. It's only the overall activation energy that gets lowered from a catalyst, and that facilitates a faster reaction.